In part 6, we have analyzed the game engine. The monitor vehicle tracker is thread safe. The thread safety relies on the monitor pattern, even though the mutable point is not immutable. The locations and its mutable points are confined inside the monitor vehicle tracker. All the getter setter are guarded by synchronized, and we never published locations or mutable point. Instead, we return a deepCopy or create a new instance. Each time we need to return a reference of the map or the mutable point. In this section, we will try to improve this code. We will dedicate the thread safety to the state variable, and we will make this state variable thread safe. We also will change the mutable point to immutable point so that we can publish a reference to the calling thread without worrying about thread safety. So in this section, we will try to avoid deepCopy and create a new instance. So let's get started. Here is a code we are trying to use. Okay. The point is immutable because first, all its state variable are final, and it is safely constructed. Also, we didn't change the x or y after we construct the x and y. So the point is immutable. Even though it is public, we cannot change it. It's a final, a primitive variable. Okay. We also need to add another public final boolean alive, and we change the constructor boolean alive. This alive. Okay, and we don't need this anymore. Now we have the point. Immutable point, and we can also get the game engine. Here we have a delegating vehicle tracker. So this time, the locations. Again, the enemy locations is represented by a map, and the concurrent map is thread safe. Let's import. Import concurrent map. Okay. Import concurrent hash map. And we change this a little bit. Replace XY and set location. We need one more which is alive. Let's pass in the parameter -s. Okay, set location, get location, and we don't need this anymore. But let's compare those two. Delegating VehicleTracker use thread safe locations, and neither the key nor the value are mutable. So the locations can be published without worry about the thread safety. Here we return a read-only version of the locations. And when we get the location, we return a reference to the point. We can publish the point this way because the point is immutable. We don't need to worry about the thread safety. Okay. When we try to modify the location, we just replace the existing location with a new one. Okay, and in this way, we delegate the thread safety to the concurrent hash map, which is thread safe. We don't need this anymore. Let's remove this. Now, those we didn't use synchronize because the thread safety is delegated to the state variable, and the public interface are exactly the same as before. So in this case, let's just try to do the string replace. Delegate VehicleTracker. Let's say monitor VehicleTracker. Let's replace all the currents to the new one. Replace all. Okay. It's we almost fixed delegating VehicleTracker, and we changed the mutable point to point. Okay. The only thing is left is this point. We need to give it instantiation parameter px, py, and true. Let's delete this, delete this. And let's change the compilation units. Okay. We have already swamped the game engine. Let's run the program. Start. Okay. This time it's behaving exactly as before. So instead of using monitor pattern, we use delegation to achieve the same thread safety. There is a subtle difference. Now we didn't do deepCopy, so our code is more efficient. And we returned a living view of the location instead of return a snapshot. So your view always sees the latest location instead of see the past snapshot, which is good for view rendering. And the point is immutable. We cannot update the point from the calling thread. In the next section, we will try to make the point thread safe so that we can change the point in the calling thread. This is the topic of this section.